Thanks, Catalyst, for inviting me to speak and giving me a chance to share our experiences. We're a new sort of payroll company. We've been going for about 2 years. How do you do this? Yeah. So I'm the co-founder. We sat down with the previous founder of another payroll company, and we sort of decided that there was still more to do in payroll. Payroll's a very sort of industry that's slow to move with technology. I mean, once you've got a payroll system in place, it's kind of left alone because you want to make sure that you pay people. So there hadn't been a lot of disruption in the payroll space, particularly in New Zealand for a long time. And when I was working at my previous payroll companies, we sort of decided that there's a lot that can be done in the space, especially with the new technology that's coming along, both in software and in the hardware. And we sort of sat down and how could we redesign payroll for New Zealand? And we've been going just over 2 years now. We started first on the mobile device. Initially, we wanted to bring payroll to SMEs where you could essentially pay your 2 or 3 employees on your mobile phone. And it sort of came out of my co-founders. He had a builder building his house one day, and it was a Friday afternoon, and he'd forgotten to pay his workers, and he was sort of talking to Asantha and saying, "Why can't you've got a payroll company, his previous one. Why can't you do this on your mobile phone?" So it all kind of started from there. So we designed it first mobile before we went web. It's New Zealand's only fully mobile payroll solution. So you can be both an employer and an employee. You can set up your payroll on the mobile phone. You can have your employees into timesheets, etc., etc. And now that we've fully implemented with Catalyst, it's, I believe, New Zealand's only what we call pay-as-you-go. In other words, you put a coin in the slot, you get a payroll service. There's no subscription per se. You can walk away at any moment. Most other companies have at least a monthly subscription. With our service, if you pay once a month, if you pay your employees once a month, then you will pay once a month. If you pay your employees once a week, you'll pay once a week. So it's literally putting a coin in the slot when you want to use the services. And we just sort of got our base product, which is payroll together, and we're also an intermediary. So we're not just doing the payroll calculations, we're actually linked with the banks. We've got a partnership with ASB, and we can pay directly through same-day processing through all the major banks. And we're also a PAY intermediary, so we actually collect money on behalf of small businesses, do their IR filing, and we take the responsibility. So if we get it wrong, we get fined. You don't as a small business. So we're really sort of focusing on taking the pain, what we like to call the pain. We want to call it payroll, not painroll, which is kind of what it is for small businesses. We want to get that people in small businesses back to doing what they want to do, which is their small business, not having to worry about paying people. So that was sort of the vision, and we started about 2 years ago. So I'll talk a little bit first, before I talk about how Catalyst has helped us, I'll talk a little bit about the software architecture, which is obviously, I've got a little diagram there. Is that the little pointer thing? That's the little red thing that you would use now. Okay, cool. So obviously there's a load balancer coming in here, which is distributing requests to what I've called front-end servers. Now most of the web requests just bounce straight off here. Anything that's a long-running process, we have the ability to drop a message on a message queue, which will effectively pop out the other end of that queue. And in the back end here, we have what I call task runners, which literally pick a message off this queue and run that task, whatever it is. Both of the front end and the back end have access to the database. So it's essentially a very, what I like to call, keep it simple sort of software architecture. It's client-server sort of stuff here, and it's client-server sort of stuff here. And we've got the ability to do asynchronous tasks, long-running tasks in the background without affecting the performance of the end of the client sitting out here, using the service. Make it scalable. We're running a a node stack. So each one of these servers is a little node instance, and we can scale them very quickly on this horizontal tier here. And this is also a node instance, so we can scale these very quickly as the demand sort of increases. And nothing changes. Everything sort of compresses down into a little node instance running on each one of these back-end or front-end servers. And of course, there's obviously a database sitting here in the background. Okay, so how does that software architecture relate to the infrastructure architecture? Well, it's really quite simple. It's almost one-to-one. The load balancer is obviously its own machine, the internet out here, obviously. And we have, at the moment, we're running 2 app servers in production, each with that full stack that I just mentioned there. So each of these instances, these node instances, are running on each of these machines here. So so the load balancer will send requests to either one, and whether it's a back-end task or a front-end task, it's running pretty much in this tier here. How the Redis or the queue comes into play is we're using Redis as a queue system with a pub-sub sort of mechanism running there. An app server, whether it be app server 2 in this case, can just drop a message on Redis, and both of these are listening to Redis as well. So don't forget, we're scaling in this horizontal tier. We've just pretty much got a compute grid that we can scale, and it will listen to the back-end task and the front-end tasks. And the load is just distributed across these evenly. And of course, we've got the database in the background, which both these 2 app servers can talk to here. So it's a very simple architecture from the software architecture that's sort of got an asynchronous thing going on there, maps very simply to the machines that we've got running here. How do we make this all sort of work? That's all the theory. When we do a deployment process, what we want to be able to achieve is we want to have less human interaction as possible, because you want to be able to replay a deployment process consistently over and over again. You want to get the same result, and you just want to make sure it works. I've worked at previous companies where we had to jump on servers, we had to do lots of little things and tricks and so forth to get things going. We had to have downtime to get deployments out there. And what we've got going here is basically a fully automated, scriptable process which is repeatable and replayable. It's using a product called Ansible, which is a scripting, what do you call those? It's like Puppet, those sort of configuration management tools. There's lots of them out there. We've chosen one called Ansible. It works on the concept of what are called playbooks, and a playbook will be designated to run a certain what they call roles, and a role is responsible. If I go back to this diagram, a role might be responsible for, say, deploying our software from, say, GitHub on this server. Another role might be responsible for setting up the Redis queue. We've got roles to set up the actual machines itself, so they're actually talking directly to the Catalyst API to actually create instances of machines. All of this is it's repeatable, replayable, fully automated, and it's done through Ansible. What does that mean? It means that I can comfortably, with my developers, once we've gone through a QA process and we've gone through a staging environment which mimics our production, I get really nervous when I deploy stuff to production. I mean, everyone should, It's like, I think, it's almost the minute if you're not nervous, that's when things go wrong, If you get too complacent, things fall over. So I'm really nervous about deploying to production. So we have a staging environment which is exactly replicating production. With this scripting process in place, I can spin up another machine. I can change the configurations of the machines. If it works on our staging, because I've just pushed a button, I'm 99.9% confident that it's going to work on production. So it's what that enables us to do at a startup. We're writing code, at great rate of knots, as you do in every startup company. But it gives me the confidence to actually do hot deploys throughout the day, depending on what it is, of course. We're patching software all the time. It's just the nature of the business. We can deploy, sometimes I've had to deploy 2 or 3 production patches in a single day, and I can do that without worrying about the continuation of the business from our company's point of view and the levels of service that our customers are experiencing. Why? Because I know it's fully repeatable and it just works. And that's this great level of confidence when you've got a million other things to keep your mind on when you're going through a startup company. So data recovery. So Bruno's given you an excellent sort of technical overview of how all the bits and pieces work behind the scenes. So what we've done is we have taken on board all of that knowledge, and particularly the things that Bruno was mentioning about the regions. We had lots of discussions about how we should do our DR our process, and what we've sort of come down to is we have a standby Bastion host sitting at another region that we can SSH into and kick off the entire process. So we've got our main server sitting in Pororua, and I think we've got one of these sitting in Wellington, and we haven't done anything with Hamilton yet, but we're certainly interested in doing that. So what does that mean? It means if we get a situation where we need to completely rebuild our infrastructure, as long as we've got SSH access to that Bastion host in a different region, we've got access to GitHub to bring down all of the source code and all of the playbooks for all of the Ansible scripts. We pretty much, this is the key thing here, there's a lot of playbooks. There's a playbook to create the instances of all the machines. There's a playbook to create the network. You do the network first. There's a small manual step where you go in there and you look at the IP addresses that all the Catalyst Cloud has assigned for the machines. And when I say the network, so we do the network first and then we do the machines, get the IPs off the machines. And when I say the machines, it's every single machine. It's the database machine, it's the Redis queue machine, it's the app servers, it's the replication database machine as well. It's all just there, and we just have to plug in the IP addresses into the script, and then we run the software deployment, and then pretty much that deploys all of our node stack. It deploys all of our extra tools that we use, and it chugs away, and we can have another copy of our entire infrastructure running in a different region within 45 minutes. Now that's pretty. We can get quicker than that, but as a startup and moving forward, we're pretty happy with that at the moment. We've just recently moved our DNS to Cloudflare. We got Engaged Catalyst to help us with that. And the reason we did that is one of the major things when you have a disaster situation is it's all very fine being able to move your machines from A to B, but what about the DNS, right? Because it's like no one can now get to it because your machines have completely moved different locations. So what's the point, So we've, what's that thing on Cloudflare that they call? The DNS is sort of abstracted. The DNS basically remains on Cloudflare, and it's a reverse proxy. Right? It's a reverse proxy sort of setup, and it solves the DNS problem where we don't have to worry about machines pointing at an environment that's no longer there. It's sort of abstracted and it's handled by Cloudflare. The object store is where we're running, on the production server, we're running hourly full backups at the moment. We'll probably be changing that soon. As we grow, we'll probably be moving that to more of a journal-based sort of backup system. But at the moment, based on what Bruno was saying, we're 100% confident that our data is actually safe based on the object store replication that's happening across the different regions. We know that as long as we can get to one of those regions, we can get our data, and that's the most important part for our customers because we've got all this payroll data sitting there. So that's sort of how we run data recovery. We went through, when we aligned with, as an ASB partner, we went through a big audit and pretty much got the big tick for what we were doing in terms of ASB's satisfaction that they were happy to put their name behind us, and etc. Looking to the future, so some of the problems we've had just with that setup is with the scripting approach, it sort of relies on the internet being there. We bring down the code from GitHub, We look at that's including building the node stack, for example. That takes time. Where we want to move with this is a process called orchestration, where we actually pre-bake the images with the version of Node, the version of MySQL, etc. So that now we're just, under the orchestration approach, we'll be basically just deploying images rather than trying to build the whole stack, which will bring that sort of DR recovery from 45 minutes down to sort of, within sort of 10, 15 minutes, because we've got everything pre-built. We're looking at things like Docker at the moment to sort of improve that process. And, it's like anything in IT. You get something going, you always see the mistakes, you can always improve it. It just, you're on the right path when your best work is in front of you, sort of thing. And the other thing, at the moment for our scaling, we still have to jump onto the Catalyst cloud, and if we're going to increase memory on machines, we have to do that through the dashboard. If we're going to add another machine, we still have to go and run another Ansible script. We have to add a machine to the Ansible script. We can just, play that, and a new machine will come on live. Where we want to sort of go with that is we want to have automated systems checking things like I'll just go back to this picture here. Things like checking if there's lots of messages on the queues here. We want to be able to spin up another piece of architecture that can put another task runner on the mix. And we want to sort of combine that with the orchestration approach so that we've got another task runner machine sort of sitting there, and it can just sort of appear and disappear when it needs to. So that's sort of where we want to go with it. We're not, we've been growing sort of about 30% month on month this year. So we're not there yet. Obviously, we're sort of, all we've had to do with the Catalyst system, with what we've got under this infrastructure over all of that time, is just increase the memory on our database server. That's all we've had to do so far. So we're sort of looking forward to the journey ahead and the challenges and the growth that we're going to be sort of going through. And the thing I like about, I'm going to say this, we actually had a big discussion where we decided to move our architecture to AWS, and we didn't. And the reason why we didn't do that is because the principles that we've got going here at Catalyst is second to none. The people here are amazing, and actually being able to call up Bruno and sort of discuss these things and actually talk through the real issues for us as a business, and as we grow, the sort of things that we would need is really comforting for us. And I think your tagline was built in New Zealand for New Zealanders, and that's a really strong thing. So that's sort of where we're at, and that's about it, really.